Well, welcome to inverses. What we're going to do today is we are going to figure out how do functions that are inverses relate to one another in various forms. So what is an inverse? An inverse is basically a function that reverses or undoes another function. Kind of like the ones that you know of are add, and what undoes adding? Subtracting, and vice versa. Or multiply, and what undoes that? Divide. And again, vice versa. So we're going to talk about inverse functions. First, we're going to start with tables. We're going to find the inverse given a table. This table is made of points. We have the x column and the y column. Those two columns, to find the inverse, you just switch x and y. It's as simple as that. So all the x's and y's switch, so -1, 5 becomes -5, -1. 0, 1 becomes 1, 0. 1, 2 becomes 2, 1. 2, 4 becomes 4, 2. And 3, 8 becomes 8, 3. Notice the x's and y's switched position. That's all that happened. Switch x and y. We didn't change any signs, just switch the x and y. And this little -1 up here means inverse. And since it's on the f, it means the inverse of the f function. There's the answer to the first one. All right, so now we have a graph, and what we're going to have is we're going to take the graph and we're going to take each point on it, which I made in color, and what we're going to do is we're going to switch those points. Well, I'm going to start on one side. This is the point at 2, 4. And this guy down here is the point at 1, 1. And this guy here is at 0, 0. And this one over here is at -1, 1. We have one more over here at -2, 4. So we learned a moment ago that we're going to switch x and y. That's how you find inverses. So I'm going to take each of those points and switch them. So 2, 4 is going to become 4, 2. So I'm going to go over 4, up 2 now. 4, 2. 1, 1, well, you switch 1 and 1, you still get 1 and 1. 0, 0, well, you switch 0 and 0, you still get 0 and 0. -1, 1 becomes 1, -1. And -2, 4 becomes 4, -2. And then we connect those dots. And that's the inverse. We just found the inverse by switching x and y of some points that were on there. There they are. All right, now this one says we're going to find the domain and range of this original function. And then we're going to find the domain and range of his inverse. And we're going to see how those are related. So we know something about functions and their domain and range. We've covered that. I'm going to start on the domain. Over on the left and the right, you know, cropping pictures. So the domain on this function, the original, is over on the negative side is an arrow, and on the positive side of the x's is an arrow. So it goes arrow to arrow, negative to positive, so negative to positive infinity. Now I'm going to look at the range. That's bottom to top. And again, I'm going to try to crop the picture if I can in the Y direction. On the bottom is arrows, and they're in the negatives. On the top, it looks like it goes up here to 1. So my range starts at negative infinity with the arrows on the bottom, all the way up to 1, where that little vertex is at. Now, I can find a couple of points on here and switch them and get their new domain and range. So I'm going to choose this one right here because he's easy to see. That's at 0, 1. And I'm going to choose this one right here. Again, he's easy to see. He looks like he's at -2, -3. And then I'm going to choose one over here. This guy looks like he's at 1, -1. So I just chose 3 points. And I'm going to try and replot those. So switch X and Y, that's our main idea. So 1, -1. Switch that becomes -1, 1. 0, 1 becomes 1, 0. And -2, -3 becomes -3, -2. Connect those dots. And look what my V has done. He's gone that direction now. And I can find his domain and his range. The domain on the left side is arrows. On the right side, look at that. It crops at 1. So the new domain, the one for the inverse, goes from negative infinity to 1. And then the range, the bottom is an arrow, the top is an arrow, so negative to positive infinity. Now let's take a look at that. The domain and range of the original one was negative to positive infinity, and then the range negative infinity to 1. And look how those relate to each other. The domain becomes the range of the inverse, and the range becomes the domain of the inverse. And why does it do that? Because we switch X and Y, which means domain is X and range is Y. So when we switch them, the domain and range switch. Really, really cool concept. And here's the picture. Now, this line right here that's dashed is the line Y equals X. That means he goes through 0, 0. And he has a slope of 1. So that line is special. And all of our inverses will reflect over him. So here's an inverse. And here's the one original function. And they are mirror images along that line in the middle. That is true of all inverses, so you need to know this. The inverses reflect over the line Y equals X. And why is that? Because with inverses, we switch X and Y. All this switching X and Y means Y is equal to X and X is equal to Y. So let's see if any of these are inverses. I have a bunch of graphs on here. And I am going to start by drawing in that line Y equals X. Because if they're inverses, then they will be symmetric over Y equals X. Now remember, he was at 0, 0, and he just chops right down the middle. Okay, those don't look the same on either side. I'm going to go right down the center again. those look pretty good. Go right down the center. Those don't look like mirror images. And then again, right down the center. And those do look like mirror images. So which ones did I think looked like mirror images? I believe this one did, because on both sides of this line, it looks like those are reflections of each other. And I believe this one over here is as well. Again, why? Because when you look on both sides of that line, you may have to turn your graph a little bit cockeyed. It looks like though it's on both sides as mirror images. So the two I circled are going to be inverses of one another. The horizontal line test. Well, back in Algebra 1, you learned about the vertical line test. The vertical line test, you usually had some kind of function. And what you did is you drew a vertical line, and if it crossed once, according to the vertical line test, it was a function. If it crossed more than once, it was not a function. So the vertical line test, back in Algebra 1, it tests for functions. Whether you're a function or not. Crosses once, yes, it's a function. More than once, not a function. But we're going to look at a different one called the horizontal line test. So you draw a horizontal line, that's the one that goes the opposite direction, it's flat. If it crosses once, then an inverse function exists. More than once, then there is no inverse function. So I'm going to draw a horizontal line. This one crosses twice, so this one fails. This one I'm going to go across, and he crosses once, this one passes. So this one, no inverse function. This one has an inverse function. Now, why is that important? Because we want to know if the function that is the inverse is actually the end function or not. So here's where we get in Algebra 2 a little bit crazy. It's called domain restrictions. And sometimes our function has to have the original function's domain kind of chopped up a little bit, so it'll pass the horizontal line test. That way its inverse will actually be a function. So let's see what that means. Well, I'm going to look at this guy right here. If I draw a horizontal line, this guy fails, and he fails miserably. So what I'm going to do is I'm going to not draw all of him. I'm going to restrict his domain. And in order for him to pass, I only need to have this line cross once. So what if I only draw one side of the graph? So what I'm going to do is I'm going to only draw one side of the graph. So at 4, he's up at 2. And then it looks like at 6, he's up at 6. So I'm going to draw 6, 6. And I'm only going to keep the right side of the graph. So what I just basically did is I erased all of that, and I kept the right side of the graph starting at 4. So I just restricted to the domain to where x is greater than or equal to 4 for the domain. I restricted it, kept 1/2. So if I keep 1/2 of the u, he obviously passes. But if I went any further over here, and made the U kind of over this way, see, he would fail. So I don't want that part. So I'm only going to keep the part that, I'm only going to keep the right side of the graph so that part passes the horizontal line test. This is a really cool concept that is going to take you through calculus. So again, here was the part that is the original function. He's restricted right here at 4. So the other half of him is no longer there. And when we take and do a switch x and y to get his inverse, switch x and y. See, this guy passes the horizontal line test. He passes. So if we switch x and y, it looks like he has a point at 4, 2, which now becomes 2, 4. And then he has a point at 5, 1, 2, 3, 5, 3, which now becomes 1, 2, 3, 3, 5. So this new one, the inverse function, when we look at him, he had our x and y switched. If we do the vertical line test, he'll pass. And that's why we chop the u in half at x greater than equal to 4. So that he will pass the horizontal line test on the original, which makes him pass the vertical on the inverse. And we got that by switching x and y. All right, now let's go to something a little bit more fun. In our calculator, we're going to figure out what y equals x cubed looks like in the table. So I'm going to do y equals x cubed, and then I'm going to go to my table. That should be up, second graph gets you the table. And so I'm going to see what is that one as a table. Well, we're going to look through our calculator. And let's see what some points are. Let's look at -2. At -2, x cubed in the table is at -8. At -1, he's at -1. At 0, he's at 0. 1, he's at 1. And 2, he's at 8. Now, this is the original table. But if I was to find the inverse, that means I'd have to switch x and y. So this would become 8, -2. Well, that's not this one. That looks like him. -1, -1. 0, 0, 1, 1. And look at that one. They switch. 8, 2. All right, so this one right here, the second one, is the inverse. And look at that. This one was actually right over here. This one's actually f of x. That was the table that we had in the graphing calculator for x cubed. So which table satisfies the inverse? We go to the graphing calculator, find table, find the original, and then switch the x and y. That's what you're going to do a lot of today, switching x and y. Now let's say we have an equation that we have given to us, and we want the inverse equation. These are your steps. Everywhere you see f of x, or g of x, or h of x, any of those function names, you're going to replace them with y. Then, just like you've been learning all day, switch x and y, solve for the new y, and then replace that y with the inverse notation. That just means this is the inverse of f of x. Let's do some. So here's my original function. F of x equals 2 times x minus 3 plus 5. So step 1, according to our chart, was to replace f of x with y. Then it said switch x and y. So y becomes x becomes y, and then solve for the new y. So I'm going to subtract 5 on both sides. And I'm going to go ahead and divide by 2 on both sides. And lastly, I'm going to add that 3 over to the other side. So I get x minus 5 over 2 plus 3 equals to y. And then the last thing I do is I write the answer, replacing y with f inverse, because this is the inverse of f. And then I write my answer, x minus 5 over 2 plus 3. And you probably noticed all we were doing was solving an equation. Let's see if we can kind of analyze this with just a little bit of basic math. I'm not even talking algebra. See how it has a plus 5? Look, there's a minus 5. Do you see it has minus 3 in here? Look out here, there's a plus 3. See here it's times 2? You guessed it, there's a divide by 2. So we're doing inverse operations for as long as you can remember. Adding and subtracting are inverses. Multiplying and dividing are inverses. So all the algebra I just did on the left is getting me to the inverse by using inverse operations. Really cool ideas. Now let's try one with a restricted domain. So all I'm going to do is I'm going to start out the same way. I'm going to replace f of x with y. And then I'm going to switch my letters. And then I'm going to start solving for y. So I'm going to add 1 to both sides. Divide by 2 on both sides. And then how do we undo a square? Well, of course, we square root both sides. Now, right here, I'm going to take a moment because up here we had a restricted domain of x is greater than equal to negative 3. Well, the greater thans are the positive side of the graph because greater than is positive. So I want to keep the positive square root down here. Normally you would put, when you square root, you would put plus and minus, but I'm going to keep the positive because of the domain restriction. He was on greater than equal to, so he was positive, so I'm going to keep a positive square root. Then I'm going to go through and finish solving for y. And I get the square root of x plus 1 over 2 minus 3 equals y. And then I rewrite that as my answer. F inverse of x is the square root of x plus 1 over 2 minus 3. And let's analyze it. That minus 1 became a plus 1. The plus 3 became a minus 3. The multiply by 2 became a divide by 2. And lastly, that squared became a square root. Pretty cool concepts. So that's going to be all of our lovely